In the vast cosmic ocean, our solar system harbors celestial wonders that ignite our imagination. Among them is a moon unlike any other, a world consumed by fire and fury. This is Io, one of Jupiter's 4 Galilean moons, and arguably the most volcanically active body in our solar system. Join us on a journey to this extraordinary moon, where we'll explore its extreme landscape, otherworldly processes, and the powerful forces that have shaped it into one of the strangest celestial bodies we've ever discovered. Imagine a world where volcanoes erupt not in centuries or decades, but constantly. This is the reality on Io, one of Jupiter's most fascinating moons. Unlike Earth, where volcanic eruptions are rare and often catastrophic events, Io experiences volcanic activity on an almost daily basis. The surface of Io is a chaotic landscape, constantly being reshaped by the relentless force of its volcanoes. Io is home to over 400 active volcanoes, spewing lava fountains that reach tens of kilometers high. These lava fountains are not just small eruptions, they are massive, powerful displays of nature's raw energy. The lava, heated to extreme temperatures, bursts forth from the moon's surface, creating spectacular plumes that can be seen from space. These eruptions are so powerful that they launch plumes of gas and volcanic material hundreds of kilometers into space, painting the moon's surface with fiery streaks. The volcanic material ejected from Io's surface can travel vast distances, sometimes even escaping the moon's gravity and becoming part of Jupiter's magnetosphere. This constant activity creates a dynamic and ever-changing environment on Io. What fuels this relentless volcanic activity? The answer is not just within Io itself, but also in its relationship with its giant parent planet Jupiter and its neighboring moons. The answer lies in a cosmic dance of gravity. Io is locked in a gravitational struggle with Jupiter, whose immense pull exerts a significant force on the moon. This gravitational interaction is further complicated by the presence of Io's neighboring moons, Europa and Ganymede, which also exert their own gravitational influences. Io is caught in a gravitational tug-of-war between Jupiter's immense pull and the orbital resonances of its neighboring moons, Europa and Ganymede. This intricate gravitational interplay causes Io to experience significant tidal forces, which are the key to its volcanic activity. This constant flexing generates immense tidal forces within Io, creating friction that heats its interior to extreme temperatures. The frictional heating is so intense that it melts the interior of the moon, producing the magma that fuels its continuous volcanic eruptions. This process, known as tidal heating, is the engine driving Io's extraordinary volcanism. Without this unique gravitational interaction, Io would be a cold, inactive world. Instead, it stands as one of the most geologically active bodies in our solar system, a testament to the powerful forces at play in the cosmos. Io's landscape is a kaleidoscope of color, but not from lush vegetation or flowing water. Instead, its hues come from a more otherworldly source: sulfur. The moon's surface is a canvas painted with yellows, reds, whites, and blacks, each color representing a different form of sulfur or volcanic deposit. These vibrant hues are a testament to Io's active geology. As volcanoes erupt, they spew sulfur and sulfur dioxide into the atmosphere, which then rains back down on the surface, coating it in these striking colors. The landscape itself is a mix of smooth lava plains, resembling solidified oceans of molten rock, and chaotic, jagged terrains, sculpted by ongoing eruptions and the constant shifting of its crust. When we gaze upon the surfaces of planets and moons, we often see a history pockmarked by impact craters, remnants of collisions with asteroids and comets. Yet, Io's surface tells a different story. It's remarkably smooth, with very few visible impact craters. This absence of scars from the early solar system is a testament to Io's dynamism. Unlike many other celestial bodies, Io's surface is constantly being renewed. The relentless volcanic activity acts like a cosmic eraser, resurfacing the moon and burying any craters that do form under layers of fresh lava and volcanic debris. This makes Io a geological marvel, a world where the past is constantly being erased and rewritten by the fires of its interior. Chapter 4. Io possesses an atmosphere, but it's a far cry from the life-sustaining blanket that envelops our planet. Io's atmosphere is incredibly thin, a wispy veil composed primarily of sulfur dioxide. This sulfur dioxide originates from the moon's volcanic eruptions, constantly replenishing the atmosphere. However, Io's grip on its atmosphere is tenuous. When Io passes into Jupiter's shadow during an eclipse, the sulfur dioxide freezes and falls to the surface as frost. As sunlight returns, the frost sublimates, transforming back into gas and replenishing the atmosphere. This cycle of collapse and reformation makes Io's atmosphere unique in our solar system. Chapter 5. Io's influence extends far beyond its own volcanic landscape. This small but mighty moon is a powerhouse of volcanic activity, with over 400 active volcanoes dotting its surface. These volcanoes are the most active in the entire solar system, spewing out vast amounts of sulfur and other materials into space. It plays a crucial role in the complex dynamics of the Jovian system, particularly within Jupiter's powerful magnetosphere. Jupiter's magnetosphere is the largest structure in the solar system, extending millions of kilometers into space and dwarfing even the Sun's magnetic field. As Io orbits Jupiter, its volcanoes release a constant stream of charged particles, primarily ions of sulfur and oxygen. These particles are ejected at high speeds, creating a plasma torus that encircles Jupiter. These particles become trapped in Jupiter's magnetic field lines, creating a flow of electricity known as the Io flux tube. The Io flux tube is a direct electrical connection between Io and Jupiter, channeling energy and particles along magnetic field lines. This electric current is immense, carrying millions of amperes of current between Io and Jupiter. The energy transferred through this flux tube is so significant that it can power massive auroras and other electromagnetic phenomena on Jupiter. The Io flux tube generates powerful auroras in Jupiter's polar regions, lighting up the gas giant's atmosphere with spectacular displays of light. These auroras are much more intense than those on Earth, due to the immense energy involved. Furthermore, Io's interaction with Jupiter's magnetosphere contributes to the planet's intense radio emissions, making Jupiter one of the brightest radio sources in the sky. These radio waves can be detected by radio telescopes on Earth, providing valuable data about the Jovian system. In summary, Io's volcanic activity and its interaction with Jupiter's magnetic field create a dynamic and complex system. This relationship not only shapes the environment around Jupiter, but also offers scientists a unique opportunity to study planetary magnetospheres and their interactions with moons. Chapter 6. Our understanding of Io has been shaped by robotic explorers that have ventured into the outer solar system. These missions have provided invaluable insights into the moon's unique characteristics and its dynamic environment. The Voyager 1 and 2 spacecraft provided our first close-up glimpses of Io in 1979, revealing its volcanic nature and stunning surface features. These early images showed a world unlike any other, with active volcanoes and a surface constantly being reshaped by volcanic activity. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, revolutionized our knowledge of Io. It conducted extensive studies, offering a more detailed look at the moon's surface and its geological activity. Galileo's mission was pivotal in understanding the complex interactions between Io and Jupiter. Galileo conducted multiple flybys of the moon, capturing detailed images of its volcanoes and providing unprecedented views of its active volcanic regions. These flybys allowed scientists to study the moon's volcanic processes in great detail, revealing the mechanisms driving its intense geological activity, measuring the composition of its atmosphere, and offering insights into the various gases present. This data helped scientists understand the atmospheric dynamics and how volcanic eruptions contribute to the moon's thin atmosphere, and observing the dynamics of its interaction with Jupiter's magnetosphere. These observations were crucial in understanding how Io's volcanic activity affects its surrounding environment and its interaction with Jupiter's powerful magnetic field. More recently, the New Horizons spacecraft, on its way to Pluto, observed Io's volcanic plumes as it swung by Jupiter for a gravity assist. This brief encounter provided additional data on Io's volcanic activity, showcasing the moon's persistent and dynamic nature. While the Juno mission, currently orbiting Jupiter, focuses primarily on the gas giant itself, it has also provided valuable data on Io's volcanic activity and its influence on Jupiter's environment. Juno's instruments have captured detailed measurements of Io's volcanic plumes and their impact on the surrounding space. These observations have deepened our understanding of the complex relationship between Io and Jupiter, highlighting the moon's significant role in shaping the environment of the Jovian system. The continuous study of Io by various missions underscores the importance of this volcanic moon in our quest to understand the outer solar system. Utro. Io stands as a testament to the power of planetary forces and the incredible diversity of worlds within our solar system. It serves as a natural laboratory for scientists studying tidal heating, planetary volcanism, and the complex interactions between a planet and its moons. The lessons we learn from Io can be applied to other celestial bodies, helping us understand the formation and evolution of planets both within our solar system and beyond. Io's extreme environment provides insights into the geological processes that may have shaped the early Earth and other planets in their infancy. Its unique characteristics continue to challenge our understanding of planetary science, reminding us that the cosmos is full of surprises.